Hey guys, today we are going to talk about properties of tangents and circles. So we're going to learn one new theorem, so the tangent theorem. This theorem says that if two segments from the same external point are tangent to the same circle, then they are congruent to each other. Go ahead and print this paper out or download it so you can write on it for your notes or take notes on paper. Okay, so practicing this theorem on number 1. So it says if two segments from the same external point, so here's the external point and here are my two segments. If they are tangent to the same circle, so remember tangent means that it does not, it's a segment that touches the circle but does not go inside the circle. See that? So see how if I continued the line, it would not go inside the circle. It just hits the circle at one spot. Even this one over here. If I continue this segment, make it larger, see how it does not go inside the circle? A tangent is a segment or line that hits the circle in one spot. That's it. It does not go inside the circle. It just touches it right there. So these two are tangents. So those two are tangents and they meet at the same point here. And they're tangent to the same circle. So that means that they are congruent. So this side is 7 centimeters. So that is exactly the same size as this side over here. So this side of the hat would be 7. I call it the birthday hat theorem because a birthday hat doesn't look like a birthday hat. See if you put little eyes in a mouth. This is a person. And there's his birthday hat. So the birthday hat, the sides of a birthday hat are always congruent. Let's try number 2. Okay, great. See the birthday hat right here on this side? See how it looks like a birthday hat right here? So this side's 15. So then the other side has to be 15. So you need to mark it. So I'm going to put one tally mark here and one tally mark here. These two are the same. So every time you see a circle with a birthday hat, right, where the segment does not go inside the circle, that's really important, then the two sides of the hat are congruent. We're going to practice that on the next problem, number 3. Okay, here's number 3. So notice how many birthday hats you have on number 3. Have this birthday hat here, right? So that's one birthday hat. Then I have the one down here. This is the second one. So I have 2, and they are not related to each other. They're totally different. So they are not congruent. This hat is completely different from this one. So let's go ahead and find the hat pieces and mark them. So here's the top one. I'm going to mark them congruent, right? They are exactly the same. And here's another hat. This is a different hat. So these two sides are exactly the same. Okay. All right. So now I look to see, did they give me any side lengths? So they told me that this side, MN, is 12. So if this side of the hat is 12, then this side must also be 12 centimeters. So these both are the same. Everybody see that? They're both 12. Now I need to find this purple hat down here. So I know that this whole segment from M to V is 22, right? The whole thing is 22. This piece is 12. So I need to find from N to L, from M to L is 12 centimeters. So I need to find the distance from L to V. So I'm going to write an X right here. I don't know what that is. So, but I know that 12 plus X equals 22. So I'm going to write that down. 12 plus X equals 22 centimeters. So 12 plus what gives me 22? You can figure that out, or we can use our algebra. Subtract 12 on both sides. So you will always subtract, right? So subtract 12 on both sides. So X equals 10. 22 minus 12, 10. So then this side right here is 10 centimeters. Let's check it. 12 plus 10, that equals 22. See how they are not the same? You don't just divide it in half. You have to subtract to see how much more you need to make 22. Go ahead. Let's try number 4. So first find all the birthday hats and mark them. So I found this birthday hat right here, so I'm going to mark it. Here's another birthday hat, completely different. All the hats are different sizes. So this one's different. I'll mark it with 2, and up here there's a third one, so I'm going to mark this one with 3 tally marks. All right, then I look to see what they gave me. So they're saying that this whole thing is 23, but there's no way I can find this piece and this piece, so I'm not going to do anything with that yet. This whole piece is 35, so I know that this bottom plus this top piece equals 35. And then they tell me that this piece from this tip to here is 8. So that's 8. So if that's 8, I know that this side over here has to be 8 because it's the same hat, right? Do you see the hat right here? That's a birthday hat. Let me draw the little face so you can see it. Okay, so there's a birthday hat there. So that's 8. And here's another one. I know that this is 8. So this piece over here plus 8 has to equal 23. So the purple piece is 8. The pink piece, I don't know what that is. But together they have to equal 23. So I can write that down, or you can try to figure out 8 plus what? 8 plus what gives me 23? Right, you could have tried it. 8 plus what gives me 23? So 8 plus what gives me 23? I subtract, right? The inverse of addition is subtraction. So what is 23 minus 8? Great, you should have gotten 15. So this side is 15. So x equals 15. So 8 plus 15 equals 23. All right, let's go on to this side here. So now that I know that this piece right here, this pink piece is 15, then I know that this side, let me get back to pink, from this point here to here has to also be 15 because it's the birthday hat theorem, right? So it has to be 15. So then I'm going to next find the bottom piece, this part here. So from this to here, I don't know what that is, but I know that together they have to add up to 35. So 15 plus what gives me 35? This, I don't know what this is. I know this is 15 plus what gives me 35. I'm going to write that down. 15 plus, I could put a question mark, I could put whatever, equals 35. And then you solve that, right? Same steps, you're going to subtract. Okay, let's check your work. So you're going to minus 15 on both sides. So 35 minus 15, what is that? So x equals, good, 20. So then this side right here would be 20. So let's check. So I have 15, the pink piece, and then this brown piece is 20. 15 plus 20, yep, gives me 35. So if this side is 20, then this side over here, the birthday hat, has to be 20. So do you see how the birthday hats are the same? 20, 20, 8, 8, 15, 15. So now I want to find the perimeter of this triangle. So to find the perimeter, remember, you add up all the pieces. There's 2 ways to do this. You can add up all the pieces. So this is 8 and 15 plus 15 plus 20 plus 20 plus 8. So you add up all those, and that will give you the perimeter. Go ahead and do that. Add 8 plus 8 plus 15 plus 15 plus 20 plus 20. Okay, you should have gotten 86. The perimeter is 86. So if I was an ant and I traveled all around this triangle, 8 plus 15 plus 15 plus 20 plus 20 plus 8, I would have traveled 86 centimeters. Okay, let's try number 5. Okay, number 5 says the 3 segments are tangent at point F, B, and D. If AC is 12, so AC is 12 centimeters, CE is 20 centimeters, so CE is 20 centimeters, and FE, so from F to E, is 13 centimeters. Determine AF. So we have to find AF, and we have to find the perimeter of the triangle. So let's see. So I'm going to start off by marking all my hats. So go ahead and do that. Here's one hat. You always mark them so you can find your congruent pieces. This piece and this piece are exactly the same size. And then this piece of the hat and this hat are exactly the same size. Now, a lot of people have done this. They just divide this by 2. You cannot do that because they're not the same. This side and this side, they're different. See that? They look the same, but they're not. You can't assume that they're the same. So you cannot divide 12 by 2 or 20 by 2. You do not do that. So look at to see what you have. I know that this hat is 13. So this piece of the hat is 13, right? So I'm going to shade this hat in right here. So see the hat right here in case you don't see it. If you can't see them, you could shade in the hats to help you. So this is one hat. This side is 13. Then this other side of the hat must also be 13. See that? So now I know this side's 13. Now I can figure out this side up here because this whole thing is 20. So 13. So from here to here is 13, right? This is 13. What does this piece have to be up here? 13 plus what gives me 20? Figure that out, please. Because the same step. So you're going to subtract. You're always going to subtract, right? So what is 20 minus 13? Go ahead and figure that out real quick. Okay, good. You should have gotten 7. 20 minus 13 is 7. So this should be a 7, right? So let's check it. 13 plus 7 must give you 20. And it does. 13 plus 7 is 20. So now I have a hat here. So I'm going to highlight the hat. So if you have a hard time seeing the hats, highlight them. See that? Color them in. Here's another birthday hat. So if this side of the birthday hat is 7, then this side over here must also be 7 because they are congruent. They have to be congruent. Now let's find the last sides of this birthday hat down here. So from here, from this point right here, B to C is 7, right? So let's find, change the color of the pen, from B to A. How big is this piece right here from B to A? Here's my other birthday hat. So let's find from B to A. Well, C to B is 7, so this is 7, right? 7. The whole thing has to be 12, so 7 plus what gives me 12? So 7 plus what gives me 12? 7 plus X equals 12. Go ahead and solve that. The same step as we just did over here on this side. Good, you should have gotten 5 because 7 plus 5 is 12. And if this piece of the hat is 5, then this side is also going to be 5. So we found all the pieces. So the missing piece, AF, what you were supposed to find, is 5 centimeters. Okay, so let's find the perimeter of this triangle. So the perimeter of this triangle is the distance around the entire triangle. So it would be, if I was an ant, I would start right here at E, and I would travel 13 centimeters plus 7 centimeters plus 7 plus 5 plus 5, and then plus 13. That would be the total distance around. So that's perimeter, the total distance around. So go ahead and add that up. Add 13 plus 7 plus 7 plus 5 plus 5 plus 13. What is your perimeter? Okay, the distance all the way around is a perimeter, which is 50. Good. Let's try number 6. Go ahead and mark all your triangles. You have 3 triangles. Mark them with 1, 2 hash marks, and 3 hash marks. Okay, so I'm going to mark, it doesn't matter which one you choose to be the first one. I'm just going to start here. And then this is another hat, so I'm going to use 2 here. And I'm going to use 3 here. It doesn't matter which ones you chose to put 1, 2, or 3 tally marks. You can even put 5. It doesn't really matter, as long as they're the same for each hat piece. All right, then now look, this is 10. This doesn't give me any information. This whole thing is 20. But it tells me here, this piece from B to E, that's 8. So from B to E to 8. So I know that this piece here, of the other piece of the hat, so all the hat pieces match up, right? So this would also be 8. All right, so you know this whole thing from B to D, this whole thing is 20. This small piece is 8. So what does this piece over here have to be? 8 plus what equals 20? Look back at your notes. Remember, you're just subtracting. Try to figure that one out. Okay, so remember, we just subtracted 8. So 8 minus 8 minus 8. Make sure you write this down so you can look back at your notes. So question mark equals, what you guys get? 20 minus 8? Good, you should have gotten 12. So this side is 12, right? 12 plus 8 is 20. So that works out. So this piece of the hat is, if this piece of the hat is 12, then this side of the hat would also be 12. Because they are the same. All right, so now I can't find this piece because I don't know what this hole is. But let's go to the other side. So this piece is 8. And this whole thing has to be 10. So 8 plus what gives me 10? Great, 2. So this is 2. So 8 plus 2 gives me 10. So that works. See, like 8 plus 12 gives me 20. That worked. So now, if this is 2 on this side of the hat, then this side must also be 2. So this total, 2 plus 12 is 14. So now I can find my perimeter. So of triangle BCD. So that's the distance around the whole entire triangle. BCD, all the way back up. So you can add the big numbers now. The total, 10, 14, and 20. Or you can add the little pieces. So 8 plus 2 plus 2 plus 12 plus 12 plus 8. Either way, go ahead and find the perimeter. Good, you should have gotten the perimeter equals 44. Go ahead and ask us questions if you need help, please. Okay, go ahead and try number 7 on your own. First, mark all your 3 different hats, right? So this one will have 1 mark, this one can have 2 marks, this one can have 3, and go ahead and solve this one. Okay, find QL. If NQ is 2, what does QL have to be? Good, you should have gotten 2. Since I found 2, now I can find LR, because this whole thing is 8. This whole thing is 8. QL is 2. So what does QLR have to be? 2 plus what gives me 8? Okay, good. You should have gotten 6. 6 plus 2, 6, 7, 8 is 8. So 6 plus 2 is 8. So if this piece is 6, then what is the other piece of the hat? Find MR. Okay, good. You should have gotten 6 also. So now I know this piece is 6. I know this piece is 10. So here's another hat piece right here. What should SN equal? If SM is 10, what should this piece equal? Great, it should equal 10. So now add up all the pieces and find the perimeter. So if I was an ant, I would start here. I would travel 10, then plus 2, plus 2, plus 6, and plus 6, and then this last piece here, 10. So add up all that, what you should get your perimeter. Okay, great, the perimeter equals 36. Try number 8. It says a bouncy ball is marketed in a triangular package to pique the customer's interest. If triangle ABC is circumscribed about circle G, find the perimeter. So you need to find it. Use what we learned about the clown hat or the birthday hat theorem to find all the missing pieces and find the perimeter. Okay, try number 9. Both of these are congruent. Which one of these would you pick? You should have picked this one here because you know that JK is going to be congruent to JM. So you set up your equation 5x minus 4 equals 2x plus 2. Okay, we set up the equation 5x minus 4 equals 2x plus 2. So remember, you have to get the x's in the same side. There's multiple ways to do this. I think the quickest way to do this is to decide where you want the variables to go. So I'm going to pick them to go on this side, the left side. So I got to get rid of whatever doesn't have an x. This is 5x minus 4. So I'm going to get rid of this minus 4. So I do the inverse operation of minus 4 is plus 4. So I add it to both sides. I put it on this side. Go ahead and do that step. So 4 plus 2 is 6. So I'm going to rewrite it. It's always a good idea to rewrite everything. So 2x plus 6 equals 5x side. My 4 is gone away, right? So now I need to move this 2x to this side of the equation, to the left side. So I'm going to subtract it because it's a positive 2x. I'm going to put minus 2x to both sides. Whatever you do to one side, you have to do to both sides. So 5x minus 2x, so like 5 apples minus 2 apples. Very good. It's 3 apples, so 3x. And whatever's left on this side, the only thing left, because this goes away, is 6. So 3x equals 6. And then your last step, I'm multiplying 3 times x, right? So the inverse operation multiplication, good, it's division. So you're going to divide by 3. So divide by 3, so x equals 2. So x equals 2. So when we come back over here, we'll do 5 times 2 minus 4. So 5 times 2 is 10, and 10 minus 4. Good, this side should be 6. And this side has to be the same. Let's check it. 2 times 2, because x is 2. So 2 times 2 is 4, plus 2 is 6. Good, so we did it right. All right, let's try the next one. Here's number 10. Try this one. Okay, we also did this in class for review of what we did last week. So remember when you have chords inside the circle, right? See how they intersect inside the circle, and these are chords. Circle one of the chords, so just pick one to circle. And then you put them equal, you put their products equal to each other. So 3 times x. So remember we did this last week. So 3 times x equals 6 times 4. So equals 6 times 4. 6 times 4. Okay, go ahead and solve that. If you don't remember, look back at your notes from last week. So 3 times x is 3x. And then 6 times 4 is 24. And your last step would be to divide. Go ahead and do all these 3, and then we'll check your answers. Okay, check your answers. Remember, there's tutorials tomorrow during Flex. If you didn't get these answers, you can show up and I can explain them to you. Okay, we also did this one. So remember, if they're outside, it's whole times out minus whole time equals whole times out. So the whole thing, so remember we did this last week. So the whole thing right here, right? 8 plus 6 is 14. So 14 is the whole thing. So I would put 14 times the piece sticking out. So 14 times, out of that 14, 8 is outside. That's the external secant. So that's 8. It's the same as the whole thing over here. So here I did 8 plus 6 to give me 14. So I have to do 7 plus x. So 7 plus x to give me the whole thing times the piece sticking out. So the external secant, the piece that's sticking out, is 7. And remember we did it this 2 ways. We can either multiply in and then solve it, or you can divide by 7. Look back at your notes. Try to do 15, 16, and 17. Okay, check your answers. Okay, try 18, 19, and 20. It's the same way. Look back at your notes. Try these. We also did these in class. Try these on your own. We're going to go over it next class time, so just try them. And the last group. Look back at your notes and try to figure these out, and we'll go over them in class.